Imagine this. It's Wednesday morning. Somebody just handed you a massive, messy tabular dataset. You're looking at millions of rows. Half the columns are raw text or categorical, and you are expected to have a working model in production by Friday afternoon. If you ask around for what to do next, the standard advice is pretty comforting. Most tutorials will tell you that all gradient-boosted decision trees are roughly equivalent, so you should just default to XGBoost. Or, if you listen to the trendy new school crowd, they'll tell you that tree models are legacy tech, and you need to build a deep learning neural network. But if we strip away the marketing hype and the podcast opinions, what does the math actually say? If we look at the 5 largest, most rigorous academic benchmarks published between 2022 and 2025, which baseline model is mathematically the strongest? Let's look at the deep learning route first. Forcing neural networks onto tabular data usually means burning massive compute budgets and spending days trying to design and troubleshoot a complex architecture. When you're on a deadline, that is an immediate trade-off. You're wasting crucial engineering hours chasing a neural network on a problem where simpler, tree-based models historically perform better anyway. You risk completely blowing your project timeline. The academic record actually points to a different answer. Across those 5 major benchmarks, CatBoost emerges as the superior single-model gradient booster. But getting that top-tier return on investment requires you to abandon some incredibly comfortable machine learning habits. Starting with the wrong default algorithm on day 1 can force you into a weekend of manual feature engineering when you could have been deploying a resilient model to production. So let's look at the data in a strategic showdown. We are evaluating CatBoost, XGBoost, and deep learning against each other across 5 massive academic studies. We'll start with Tabarina from June 2025. This is a living benchmark maintained by the AutoGluon team at Amazon, people who optimize machine learning models for a living. Their methodology is crucial here. They ran CatBoost with conventional tuning, and critically, they allowed it to process categorical columns natively. Instead of manually pre-processing the data, they let CatBoost use its built-in engine. The result of that test placed CatBoost as the #1 outright performer against the entire field of gradient-boosted decision trees. We see the exact same pattern in the 2023 Tabzilla benchmark, which tested models across a suite of 176 different datasets. Mean rank scores tell a clear story. Lower is better. CatBoost averaged 5.06, XGBoost at 6.38, and LightGBM trailed at 7.80. Note the handicap. Tabzilla restricted the tuning budget to 3 hyperparameters. CatBoost achieved its dominant rank with its advanced tuning surface completely untouched. For out-of-the-box, single-model performance, CatBoost mathematically dominates the legacy defaults, saving immediate production hours for time-poor practitioners. Now, what about the recent hype around deep learning models like TabPFN matching tree-based performance? To answer that, we have to look at the 2024 Talent benchmark, which is the massive 300 dataset study people usually cite as proof that deep learning is caught up. There is a massive caveat in those results. Deep learning only matched or surpassed gradient boosters on a very specific slice of the data, datasets with fewer than 10,000 rows, where the features were strictly numeric. But across the rest of that 300 dataset suite, CatBoost maintained its lead. On categorical heavy data, CatBoost led. On chemistry data, CatBoost led. On complex finance datasets, CatBoost led. Deep learning is a credible, working tool for small, perfectly numeric datasets. But for the messy, categorical heavy reality of enterprise data, it remains a fragile and inefficient choice. Sometimes CatBoost wins even when the testing environment actively works against it. The comprehensive Shmuel benchmark from August 2024 found that CatBoost won outright on 19 out of 111 datasets. While 19 wins is more than enough to beat XGBoost, it actually represents an artificially low floor for CatBoost due to a methodological error in how the test was run. The researchers passed all the categorical data through a generic 1-hot encoder via TPOT before handing it to the models. By converting those categories into sparse ones and zeros up front, they completely disabled CatBoost's defining feature, its native ordered target statistics engine. We see this kind of blind spot elsewhere too. The highly influential Grinstein paper from 2022 famously proved that tree-based models outperformed deep learning, but they tested XGBoost, Random Forest, and scikit-learn while completely excluding CatBoost from the study. The team behind Tabzilla retroactively fixed this omission the very next year. They ran CatBoost on a superset of the Grinstein data, and predictably, CatBoost ranked #1 among the gradient boosters. Even when handicapped by legacy one-hot encoding pipelines or completely ignored by early papers, CatBoost's underlying mathematical architecture still overpowers the tabular field. Pulling all of this together, those 5 major benchmarks reveal one consistent pattern. CatBoost consistently ranks as the strongest single-model gradient booster for large-scale tabular data. This quadrant chart maps options by implementation effort versus predictive impact. The legacy XGBoost approach, with its manual feature engineering, sits firmly in the middle. Deep learning requires high effort for highly variable impact. The basic CatBoost approach yields top-tier accuracy with low effort. Achieving this high-impact return requires you to let go of comfortable, entrenched scikit-learn pipeline steps. You have to let the model do the work. If you are pragmatic, time-poor, and need a reliable production model by Friday, bypassing one-hot encoding and running CatBoost natively is your definitive answer. But what if you are a Cackle competitor, or your specific project demands the absolute maximum performance possible? Remember that Tabzilla benchmark. CatBoost achieved its #1 rank, with a massive amount of performance room still available if you use the right settings. Capturing that extra margin means you have to understand advanced, library-specific concepts like prediction shift bias and symmetric tree structures. That is the trade-off. You can't blindly call a fit function. Accessing those performance gains requires an upfront investment of your time to genuinely understand how the tool processes data. The book Mastering CatBoost and its companion Pro Edition notebooks are the definitive shortcut to learning this advanced tuning surface and categorical encoder strategy. Adopting CatBoost makes your baseline competitive immediately. Learning the underlying architecture gives you the tools to handle tabular data at a level